you still have to understand that these things are all different. And so your solution and your approach at an industrial scale has to be, all right, I understand that this is different. So part of my software paradigm is that I've built in to my solution this understanding of difference, right?
Yeah, that's very complex.
I don't know how to say it, hyper-connectorization.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsipher, Chief Solution Architect, author, and most importantly, your host. On today's episode, Revitalizing IoT, with special guest CEO of IoT 83, Lee House. Lee, welcome to the show.
Great to be here, Darren.
Hey, Lee, before we drop into a passion of mine, which is, edge and diversity of edge, I just finished my dissertation on this about a year ago on specifically on edge security and the whole bunch of things around that. But before we get diving into there, everyone that listens to my show knows that I only have superheroes on the show, and every superhero has a background story. So, Lee, what is your origin story? What's your background story?
Oh my goodness, my background story, and throwing that into a superhero context makes it challenging.
Well, yeah, I wouldn't have anything less on my show. Why would I?
Well, so thanks. I guess Lee's superpower, right? If I have one, is to understand the context of business needs, in the moment of current technology. So we've got all of this.
That's a pretty awesome superpower.
Well, I grew up at IBM as an engineer, and people would tease me and say, "Lee, you don't sound like an engineer. You sound like a product manager." So it was always this, being on one side, what does the customer need, and then being on the other side, what are the available technologies? And so it's really been fun for me throughout my entire career to try to create that product market fit, and it's also interesting because the sort of edge of the archetype, if you will, is always changing. So it's constantly moving forward. The needs of the customer are constantly moving left or right. And many times we find ourselves trying to use technology to solve a problem that is not a real problem. So that whole thing has been a lot of fun throughout my career.
It's like, I've got the technology, I'll find a problem that I can use it with, right?
Well, I don't want to get too off topic, but at IBM, we built the first wireless LAN, and we were the first people not paying attention in meetings because we were on the internet, and we could not give it away. We tried to give it to the highway patrol. We tried to give it to fleet management. We tried to give it to warehousing. Nobody wanted it. 2 years later, everybody had to have it. So there you are.
There you are. That's crazy. Yeah, no, there's lots of interesting technologies that never saw the light of day until like 10 years, 20 years later. And then everyone needs it now. And you just go, well, yeah, but that's been around, right? Why didn't it succeed the first time?
We just weren't ready, I guess.
Yeah, I guess. So Lee, incredible background. And I love your positioning, because we do need people that can help bring the technologies that are there today to solve real problems. So let's drop into the real problem space that we're dealing with IoT. I remember 10 years ago, IoT was going to revolutionize the world and change everything. And in Industrial Revolution 4.0 was going to just change economies and everything. And it kind of did, but it kind of fizzled a little bit.
Well, I think we had a long gestation period, and some of the early hype. You're right. We were a little bit ahead of ourselves. I mean, there was a lot going on that would cause us to be excited. I mean, there was the cost of edge computing was dropping like a stone. There was all sorts of edge sensors that were available. I guess at that same time frame, what I'd call the Raspberry Pi revolution was happening as well. So you had this sort of convergence at the edge where there's cheap, abundant sensors, low cost compute, and then this availability of edge processing that just sort of made everyone understand how quickly these solutions could be brought together, and how much that could be done with them. So everybody saw and understood the opportunity, but then pulling all of that together became tricky. So it's one thing to build a prototype. It's another thing to really look at what does it take to build enterprise class solutions, especially with the whole notion of IoT, where it's all about scale, scale, scale.
Well, I'm glad you brought that up because the technology was way far more advanced than the processes to manage those could keep up.
Right.
Right. I even look at my own home. I've got IoT all over my whole house. I have 72 devices in my house that are on my Wi-Fi. Right. And there's no real good central management of all those devices. If I look on my phone, I've got like 7 or 8 apps that manage, 72 devices. Why can't there just be one? Right. I can't even imagine what it would be like in the enterprise. I mean, my house is my house. It's not that complicated, right?
Well, interestingly, there's a different dynamic going on in the enterprise, and certainly, to your point, it is extremely complicated in the enterprise, and we can dig into that. But there are commercial reasons that the consumer is gonna be divided, and you're gonna have Nokia, you're gonna have Samsung, you're gonna have all of these different you know providers that have a vested interest in their brand. And so,
Right. Yeah.
at the residential and consumer level, that's hard to fight. And candidly, we never went there with. We'll talk more about IoT 83 later, but we never went there. We always were focused more on the enterprise solutions where there is a really strong motivation to solve this diversity problem. Right? You've
But
got.
isn't the diversity problem similar though in the enterprise space in that all the big players in edge and IoT devices want to lock you into their brand and
Well, you're
into their
right. You're right.
solutions.
That's a really good point. And so you've got this sort of these hierarchies of needs. So the gateway provider, for example, the gateway provider wants to maintain their brand. Maybe it's Dell or maybe it's Intel. They want you to buy their product, and of course they want to be able to differentiate at that layer, and that's important. And same thing is true of like sensors, right? You've got sensor solutions that can be attached to various assets, and those brands want to be shown. But in the end, the enterprise has to be able to pull together a solution. And we were talking earlier about 10 years ago, IoT came on the stage, and what was the delay? Well, the delay was part of this sort of conflagration of all of these different vested interests and trying to harness this all into something that could actually be used. And so, again, I think it's the commercial need of these enterprise class solutions to be able to overcome the different, I don't know, brand awareness and hierarchies and biases in order to use standards to build solutions to overcome this.
You mentioned the S word, standards, right? Are there standards that everyone's now following, or are they still kind of doing their own proprietary protocols? Because I know that's been a problem in the past, right? That, hey, if I buy something from Siemens, it doesn't work with GE stuff because they're using different protocols on the back end. And it's almost like they do it to lock out competition from moving into their space. Is
Yeah,
that are there standards out there now that people are like, all right, we're going to be the first ones to move into the standards and make it more accessible and easier to integrate across all these different devices and
yeah,
device
yeah.
types?
Well, I think less. My view is that the sort of proprietary protocols are less of an issue than the brownfield protocols. So you've got like
Okay.
Modbus and OPC UA and all of these sort of legacy protocols that exist, and they're all in industry. Products are made to last 20 or 30 years, right? So you've got this long tail of products that have to be integrated into these, modern protocols. And so, yes, I feel like the modern protocols, the IoT, protocols have really come a long way, and people are embracing them, particularly MQTT, right? TLS security, MQTT, that's really become the sort of common ground, even though there's a lot more, HTTPS, et cetera. But I think solving this Tower of Babel has become more better handled now at the edge. So we've got a lot of edge gateways that can take all of these various protocols and bring them in and normalize those protocols into protocols like MQTT over TLS, for example, and bring this solve the Tower of Babel. But then you've still got the challenge of diversity from what does the data mean, right? So you've got
Yeah.
yeah,
So
yeah.
I like that you brought that up because being able to get everything to at least come into like MQTT or HTTPS, I got the gateways to help me to do that. But a simple thing, and this caused a multi-billion-dollar failure on a Mars rover. Temperature. What am I measuring it in? Fahrenheit, Kelvin, Celsius, right? What I mean, what is it in? And without knowing that and having context around that, this is a real problem.
That's right. That's right. That's right. So our first problem, we're going back to what did it take to get IoT, out of the sort of the doldrums. First was solving this Tower of Babel, but then the next
Right.
thing is getting to sort of a design pattern understanding of what needs to be done in order to contextualize data. And so everybody started talking about digital twins. So the digital twin is a great sort of and very understandable way to talk about contextualizing data. So when you have data coming in from a sensor, it could just be a single data point. What does that sensor mean? What is the digital twin for that end device? So you're not thinking of a reading, telemetry reading, as much as you're thinking of this is the asset. What is this asset doing? What is this asset for? What does this data mean? And so building a digital twin is, of course, the digital model of whatever that asset is. And the beauty of the digital twin is that it can contain, near real-time data. It can contain metadata that provides context for what that data. It can contain your units. What units
Yeah.
is
What unit?
is this temperature
So,
measurement in?
so are you finding that most of, well, for brownfield, that's different, right? Because digital twins did not exist. So I have to build those digital twins for all those brownfield devices that are, maybe only 3 years old or 4 years old.
Right.
Are we seeing with new devices coming out that the vendors are providing digital twins with the physical device as well? Are we
Well,
seeing
well,
that
Well, it all
trend?
depends. So this is back to hierarchy. So if you're providing I don't know, a relatively simple device that is used in a larger context in a industrial system, probably not. You're just providing the product itself, the asset, and then the data feed associated with that, because that asset is then going to be used in a lot of different contexts, right? So
Right.
the,
Yeah.
the foundational layer, of a digital twin might be there. What is this name value pair, temperature and, what have you, and some level of context about what is the release level of the product that is reporting this data, et cetera. But then the cool thing about digital twins is that, and particularly as we move from sort of thinking about the edge to thinking about the cloud, right, or a more complex industrial IoT solution, whether it's on the cloud or on the edge, is starting to bring data from individual assets or sensors, right, into systems. So now you can build a digital twin for a system and start to apply more and more context to whatever it is that you're actually trying to optimize.
Okay, so that's good to differentiate because I don't necessarily need to have a digital twin for every single IoT device in my system,
Right.
right? Sometimes I can, like, I don't need a digital twin for a thermostat,
Right, right, right,
not
right.
necessarily, right?
In this case, you're really more interested in a digital twin. I don't know whether it's a digital twin for your HVAC system, right, or
Yes,
digital twin even for the entire building, right? Because these, you can even build a digital twin in what we do build digital twins in smart building that take into account, what is the temperature, the ambient temperature outside today, and what is the thermal leakage, of the HVAC relative to the thermal radiation from the sun, right? So we take all that, you can take all that into account, or it can be relatively simple, right? Just trying to optimize the servicing of the HVAC system.
so that digital twin kind of gives me the context a
Right.
lot better, right? Between these individual IoT devices that are sitting out there, a lot of them are some types of sensors. There are actuators out there as well, but a lot of
Sure.
them are sensors,
Right.
right?
Right.
That are saying, here's my data, here's my data, here's my data. And they're dumb. I hate to say we call them smart edge, but they're really dumb, right? They
They're not
just,
smart. They're not smart until you do something with the data, right?
yeah, exactly. And,
Yeah.
and so having the context and that digital twin gives me that context on, hey, these sensors are these two thermostats, which I've got six little sensors I have throughout my house that tell me the different temperatures in different rooms to try and balance out everything. It's really nice if they know where they are with relationship to each other,
Right.
right? That's context. That's that digital twin concept, right? Is that explaining it?
Absolutely.
Okay.
And so there's sort of multiple dimensions of this in terms of creating value. So, you've got we talked about, is it just a data point, a single sensor, or is it part of a system? So what is the context in the system? And then, what level of, as you bring in more pieces of data, you have the opportunity to say, okay, well, what matters in this system? What threshold crossing events have relevance?
Right.
What analytical measurements have relevance? What might we apply AI or ML modeling to? So you continue to take the different pieces of these digital twins to add, moving really from sort of a monitoring, initial monitoring level to more of an analytical level for creating more reliability or optimization or even asset protection, right? In your home, in your example, the temperature gets to a certain point, and my God, that's on fire. Let's
Yeah,
call
yeah,
the,
yeah, yeah.
call the fire department. Asset protection is part of this as well. Somebody buys a multi-million-dollar generator. You want to know where is it running off the rails to protect my asset. But then taking it still further into, we talked about the various levels of intelligence. Whether this is just a basic rules and threshold crossings, or algorithms that we write because we understand the system, or AI ML models that we deploy because we understand certain components of the system, derived data that we can compute, or large language models, what have you. We start to create this deeper and deeper understanding of this data that is coming in. But then on another level, we're starting to add, what are this piece of this system influences this piece of this system, influences this piece of this system. So we're trying to build all of these things together into a more complicated total solution. And then once that's done, so you've got the depth of data, depth of
Right.
knowledge and analytics, and then you've got the system level view, and then you've got the business level view, right? So now how do you tie all of this information and data into your business? Because in the end, what are you doing it for, right? You're
Yeah,
doing
you're
it to
doing it to make
optimize your business,
money, right?
right?
Yeah,
You
or to,
want you want better service, you want incremental revenues, you want again capital protection of devices that were purchased. You
So,
want
so
smoother
Lee,
operation.
I got to
All that
back up
stuff.
just a second because this is very different than software development that we're used to, right? Because and I'm a software engineer, so when I develop something, I can develop it once and deploy it anywhere. But these types of systems are not like that, right? Because every single building, let's talk about smart buildings just in general. I can't cookie cutter a smart building.
Right.
I can't just say everything's going to be identical in every smart building unless everything's painted the same,
Yeah.
everything has the same square footage and same rooms and all that. That's why these systems are so complicated, is because they're unique every
It's
single
been, and
time,
we go
right?
back to your original premise of 10 years ago we were talking about IoT, industrial IoT, and how it would solve so many things. Well, and it is, but this is exactly the problem: is this uniqueness? Because in on the one hand, everything is unique, but on the other hand, let me discuss this a little bit. There are very distinct design patterns that repeat for different vertical markets.
Types of
Right?
vertical. Yeah,
Exactly. Right.
no,
So you've got
I agree.
all back to our earlier premise. We've got all of these different suppliers of gateways and sensor devices and all of that. So there's an area of uniqueness that has to be overcome, and that's overcome mainly through standards with security practices and protocols, right? And then people leaning into this notion of digital twin, so it makes it easier for you to produce a digital twin because you can better understand the context of the device. Okay, so that tends to make it easier, but you still have to understand that these things are all different. And so your solution and your approach at an industrial scale has to be, all right, I understand that this is different. So part of my software paradigm is that I've built in to my solution this understanding of difference, right? So
Yeah,
sort
yeah,
of
that's very
hyper
complex.
connect. I don't know how to say it. Hyper connectorization, right, becomes a really important thing. N to M to O to P. You're
Yeah,
connecting all these
yeah.
different things in a secure way. So that's I think really really interesting and important.
Well, and
Um,
we haven't even talked about all this variability in systems is really difficult to manage
right.
because anytime I have variability, and I learned this when I was in MBA school, I'm a Deming zealot, right?
Yeah, yeah, yeah.
His whole thing was to decrease the amount of variability as much as you possibly can in the process, and do that up front if you possibly can. But these big industrial systems and or smart cities or smart buildings, by definition, have high variability in some of the systems, whether it's weather, because we're dealing with the real world,
Right.
right? The physical world throws a lot of curveballs into things, right? Then you add people into it, and oh my goodness, now you've got mass chaos going on. So how you talked about driving variability out through standards, through digital twin. What are some other techniques I can use to drive out some of the variability, or do I embrace the variability, which
Well,
complicates my software packages?
I think you clearly want to drive it out where you can, and we can come back to the design patterns a bit. Try to leverage the design patterns, but I think you definitely have to embrace it. When you look at IoT, industrial IoT systems, you've got several areas of high churn, right? So there's high churn at the connectivity, right? What sorts of, and the interesting thing about IoT is it is not just IoT. It's you're connecting to software systems, you're connecting to databases, you got all these different sources of data, right, that are important to this overall solution, right? So areas of churn at the data connectivity, right? So what do? You embrace that. Say, okay, I know I'm gonna have these um, call them this set of standard protocols. So I need to be prepared to support that. I know that I have to have security, absolutely in industrial solutions. So secure connectors everywhere. And I know there's going to be some sort of oddball things that I need to connect to as well. So having that capability to integrate you know custom edge, or rather custom connectivity solutions. So area of churn number one. Area of churn number two is in the custom business logic. So you're gonna, all of these solutions are gonna have something unique about them because these are being sold by companies that want to have differentiation, right? So
Yeah,
there's,
yeah, yeah.
there's something specific and unique about their value proposition that they have to be able to produce. So having the ability to add custom business logic and custom analytics, and so that can be as simple as threshold crossing and rules, creating the ability to create that, embrace that because it's going to be different, right? The ability to create and instantiate algorithms, right? What it's just code written by people that understand how a system works, and then the ability to instantiate AI and ML models, right? Because that's an important part of it, and then the ability to pull in all of the manuals and user logs and different information that might be needed in LLM models, right? Because that's really important in where we are at this stage with IoT as well. So second area of churn, custom business logic. And then the third area of churn is in the user interaction. So the custom dashboarding, all of the visualizations, the role-based access control, because these systems are multi-million-dollar systems. They're not just being used by one type of user. They're being used by someone who's responsible for operating the building, someone who's responsible for fixing the broken valves, someone who's responsible for rolling the truck out to the customer site, or someone who's responsible for managing the overall enterprise. So
So
these
you know
three
something
areas
that
of
hit
churn, I think you really have to embrace.
yeah, something that hit my mind on that was in my own house. I want RBOC in my own house, role access based on the thermostat,
Uh-huh.
right?
You don't want anybody else to change it once
Yeah,
you've
yeah, yeah.
decided.
I want my wife and I the only ones that can change it. The others can
Or at
look at
least
it.
you're letting your wife change it.
Well, yeah, absolutely, right. But when my kids come and visit, or my grandkids come, they're all messing with the thermostat. I'm like, who's messing with the thermostat? We have this all set up. So I get that role access based is really important.
Well, it's critical.
Role
I mean,
based access
because
management.
when you're talking about industrial, and so we talked earlier about the evolution of these systems and how they become more and more and more capable and powerful. As you move up this curve, you want to allow more and more levels of automation and autonomy. So
Right.
you
Yeah.
absolutely cannot do that unless you strictly control, this role-based access control. Only certain, we have to have, in these industrial IoT solutions, you have to log any of the changes. You have to understand why anything was changed, who changed it, when did they change it. All of this stuff is essential, and then you need to be able to control who has the authentication, who has the authority to make these changes. But at the same time, don't make it so hard that this uniqueness of the solution becomes a burden.
Well, I love that last part because I think that's been the problem in the past. We've
Yeah,
made it so difficult
yeah,
to do this that people said, well, I'm not going to do it. They
yeah.
buy IoT devices, but they don't integrate them into full systems,
Right,
right?
right,
That's some of the frustration that I have with my home automation is I don't have a central control. I've got 7 or 8 different apps. I'm like, I'm even going to try and tie them all together because I'm not, right? Unless there's a single place that I can go and say, when I'm on vacation, make sure all the lights are turned off, all the doors are locked, the AC is set appropriately, or the heating, or whatever. I want to just say, I'm on vacation and it do all this instead of me going to 5 different apps, which is what
right,
happens
right, right,
today.
right.
And I go and my wife goes, are you sure you turned off the lights? And I'm like, no, I'm not sure I turned off the lights. I got to go do that. So I see the purpose in this. Now, for you guys, Lee, do you guys with your solution stack, are you offering more of that centralized view of all of these, that systems view? Is that your approach then?
Well,
Because we've
yeah,
talked a
yeah,
lot about that.
absolutely. I mean, what what we have to be able to do as a software provider to these industrial systems, to large OEMs, right? We have to have sort of a gosh, we have to offer solutions that allow them to be extremely sophisticated in some areas and sort of beginning to walk in other areas, because the different parts of the business will have different criticality, and they'll
Oh
have
gosh,
different
what a
velocity
nightmare.
in terms of going to market. So you'll have some pieces of the business that are sort of on the asset performance management, asset lifecycle basic end of the spectrum. Some pieces of the business that have built these complex digital twins and are beginning to add more and more systems to the digital twin and adding AI and ML and LLM solutions, right? So it's everything in between. Some systems are only concerned with the connection of the telemetry data, and some systems are tied to multiple other enterprise applications in order to make the most value. So it's all of this, right? We talked earlier about the challenges of how do you make it flexible yet not so hard that you can't use it,
Right.
or
Yeah.
so expensive that you can't afford to run it. So this has been one of the big problems in this industry is first thing on the first folks that showed up on the scene were sort of call them the mega OEMs, right? The IBM with their predicts. I was actually I'm sorry, GE with their predicts. I was
GE with
actually there.
Predix. Yeah. Yeah.
Yeah,
I
I
actually
was actually
helped
there.
with that project a little bit.
Hitachi, Siemens, these are great solutions if you have a lot of GE or Siemens or Hitachi gear, right?
Exactly.
Yeah, yeah.
Yeah.
But trying to use those to build custom solutions was just horrible, right? Because you're just not appropriate for that. Millions of lines of code that are specifically oriented towards certain paradigm. And so the next thing to show up on the scene is the IoT as a service, right? From AWS and Azure, and really, they look fabulous. And in terms of building a prototype of something, you can do it almost over the weekend, right? And that these things are scalable, so you can build something that is you can construct virtually anything using the components from these systems, but you have to realize that they themselves are components. They're not really platform. They're components to build a platform with. So if you embrace that, you've just embraced a long-term maintenance debt, technical debt, uh, going down that path. And not only that, you have to hire all of the specific skills, et cetera, and so on. But you've got the extreme versatility, right? The next thing to show up on the scene is the low code solutions, right? So
Right.
they're
Yeah.
more or less canned solutions, and they are, focused on industrial solutions. But I talked to you about the areas of churn, right? You've got the connectivity, you've got the custom, the custom logic, and you got the dashboards. Well, these solutions are very focused on that, but the large OEMs find that they don't have enough flexibility or versatility or scale to be able to leverage that. So, what we have tried to do with IoT 83 is we've tried to, zero in on this sort of challenge, right? You've got on the one hand, it's really expensive, long time to market, high maintenance costs to leverage the sort of IoT as a service solutions. On the other hand, you've got the low code solutions that you just can't really build what you mean to build. And
Right.
we've
It's
tried to
it's
find
not
the sweet
flexible enough.
spot. We tried to find the sweet spot in the middle that gives you all the flexibility that you need for differentiation and value creation without all of the technical debt and cost and risk and time to market. It's been a
Well,
challenge. We're on the sixth version of the thing. So,
oh, I
yeah.
bet. Yeah, no, no, this is a very complex, much more complex than any other type of software that is done because you're bridging a gap of a very oh, I'm not going to use the word archaic because that's not the right word. Very well established industries that don't see eye to eye on things. Software, the software side and IT side and the OT side, they just don't. They don't even understand. They don't even use the same languages
Well, it's
to
interesting. One
understand.
of we joke around, and it's really not that big of a joke. Our biggest competitor is the internal engineering teams,
Yes.
because they think that this is cool and they want to do it themselves. But where we are successful in convincing the business leaders that they should leverage folks that do this all the time.
Yeah.
It just accelerates their innovation. So they're not reinventing this,
Things that you've already done.
resolving this problem that we've been focused on for almost 10 years. They're just leveraging it for more innovation,
Hey,
leveraging
Lee.
their expertise for what they really know how to do and
Well,
create this
that's
value.
right. That's absolutely right. Right. And Lee, if people want to find out more about you and IoT 83, where do they go?
Well, IoT83.com. We've got a comprehensive website. There's all sorts of information there. I also publish weekly articles on LinkedIn that are focused on different topics around enterprise grade IoT solutions and AI and ML. All of those things ultimately get published on the website as well. But those are both good places to learn more about IoT 83.
Hey, Lee, this has been great. I'm glad I don't get to have guys like you on the show very often. I need to do this more because this is a passion of mine, right? This is an area that I think is extremely important. So thanks for coming on the show and sharing with my audience.
Well, it was really fun for me. Anytime, I'd be happy to do it again.
Sounds good. Thanks a lot, Lee.
Cheers, Darren. Thank you.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.